Hello, I'm Brian Tarrant. I'm the head of data science platform at the Royal Statistical Society. And in this series of short videos, we are previewing some of the papers and sessions at the upcoming RSS conference in Aberdeen. Today, I'm joined by Dr. Charles Paxton, a research fellow in the statistics division of the School of Mathematics and Statistics at the University of St Andrews. Hello, Charles.
Good morning.
Good morning. Thanks for joining us today. So you're speaking in the 2 p.m. session on Wednesday, 14th of September, and that's Statistics of Strange Species, and that's part of our Applications of Statistics topic stream. And I have to say, your paper title instantly grabbed my attention. The Loch Ness Monster. What do the statistics say? What can we expect from this presentation? It sounds fantastic.
So I'm going to be looking at 86 years worth of eyewitness testimony or eyewitness reports from Loch Ness and looking at what are the patterns in the observed data. And notice I use the word data there because part of the argument that I'm going to be making is that this sort of testimony, with caveats, can be used as data.
Right. Okay. So when you've got these anecdotes and you're using them as data, what is it that you're kind of looking for? What are the patterns that you're hoping to kind of draw out from them?
Well, I'm still exploring the data. So the analysis I'll be giving at the conference is the kind of initial analysis where I'm trying to find out whether there are any clusters in what's reported. So can we divide up the reports into types? And then having done that, are there we can then look at how the proportions of those different types fluctuates in time. And that perhaps will give us an inkling into the Loch Ness phenomena as a reported phenomena. So it's sort of saying, well, is it just a natural phenomena, or is it perhaps influenced by sociological things that are going on around the loch?
Right, and because it's certainly not going to be able to say, this is not looking for evidence of the Loch Ness monster itself, right? It's about looking at analyzing the evidence that we have, if you like.
Yeah, it's I mean, I am personally a Loch Ness monster skeptic, as are my co-authors. But our point is that the Loch Ness monster does exist as a sociological phenomenon. It does exist as a reported phenomenon. There may be, okay, some people believe it exists as a biological phenomenon, but it undoubtedly exists as a reported phenomenon, and we can treat those reports as a sample of a statistical population, which means we can make inference about things that have happened through time in these reports from Loch Ness.
Okay, excellent. So I had a little look at your website before the call today, and that's c-monster.info. And so it seems to me you've done a fair amount of work, not just around the Loch Ness monster, but other unknown large aquatic animals. So what sparked your interest in this field of research?
Um, Boyish enthusiasm. So I mean, it was a topic that always interested me as a child, and as it probably interested lots of people as children. And I began to think that it was a topic which actually could be explored far more in a far more scientific way than many people thought, using statistical techniques. I mean, that's kind of my kind of interest, and um, it's kind of quite a controversial topic because I'm also interested in the philosophy of science, and there's questions about whether studying this sort of thing is fully scientific or not fully scientific. And I personally think that my co-author's approach is scientific, and so it's kind of interesting to apply conventional scientific methods, statistical methods as well, to try and elucidate this reported phenomena, and to ask questions about what is. Well, my other work asks questions about what are the are we likely to discover new species, large species, and these sorts of questions.
So that's an interesting point, actually. So you're a skeptic about the Loch Ness monster, say, but I think on your website I saw a bit of text where you talk about, that undoubtedly there probably are creatures we've yet to observe that exist that we just haven't seen yet.
Yeah, and I'd actually say that 100%, because if you look at the rate at if you look at a cumulative this is a paper I did in 1998. If you look at the cumulative numbers of animals described over the last 250 years, so if you can imagine a graph with time on the x-axis and cumulative numbers of species described on the y-axis, where the species under consideration are greater than, say, 2 meters long, which seems a big size. And if you plot that, that curve hasn't reached an asymptote. So it hasn't flattened off yet.
Right.
And so that tells us, really, without any, I think, with really any doubt at all, that there are unknown animals out there. Now, of course, those animals might not be being seen by people. So I'm not necessarily saying that every time someone claims to have seen a sea serpent or something like that, that's real. I don't think that's necessarily the case. But the simple question are there unknown animals out there, large unknown animals out there? Well, the answer is undoubtedly yes. And not only that, I mean, my paper came out in 1998, and several new species have been described, new large species have been described since then. Some of them are kind of cryptic species that are only revealed through molecular genetics. So you could say, well, they're not real brand new species. But other ones are really quite kind of unique things that weren't seen before, like a large ray greater than 2 meters either wide or long. I can't remember that was described. When was that described? In the late 1990s or the early 2000s. So there are now that an animal like that is benthic. It lives on the sea bottom, so that's not going to be seen by people. But there are big animals out there, and I think that's worth telling people and saying, well, you know, we can use statistics to predict that.
Yeah, excellent. So tell us, if you can, a little bit about the wider work you do at the University of St Andrews. So you're based within the Centre for Research into Ecological and Environmental Modelling. And so what's the focus of your work there?
So typically with that kind of, for my mainstream proper work, what I get paid for, but I'm not teaching, is I analyze data from typically marine mammal surveys, where people have gone out on boats and planes to survey for marine mammals, and they collect the data, and then someone like me comes along and we turn the observed data collected, into maps of abundance and estimates, maps of density and estimates of abundance.
So it's still very much an interest in marine creatures, marine animals, and their behaviour and things like that.
Yeah. My interests are kind of in aquatic animals more than terrestrial animals. But you can apply these techniques to estimating terrestrial animal abundance as well.
Okay. And was that also similarly inspired by your boyish enthusiasm for stories of the Loch Ness monster?
No, well, I mean, I had an interest in natural history. My first degree is actually in zoology.
Oh, okay.
So it's really just an extension of that. I'm a sort of, yeah, I'm just trying to think of the word, quantifiable zoologist. No, quantitative zoologist. Quantitative zoologist.
Excellent. Well, it sounds like fascinating work, and I'm really looking forward to your session on the 14th of September and finding out a bit more about what the statistics can tell us about the Loch Ness monster. So thank you for giving us a preview of your talk, Charles.
Well, thank you for interviewing me.
Well, so the RSS International Conference 2022 takes place from the 12th to the 15th of September at P&J Live, Aberdeen. See rss.org.uk/conference for the full programme and details on how to register. Thank you for watching.